I'm Wim Slagter. I'm the Director HPC and Cloud Marketing at Ansys. I'm part of the corporate marketing team. If I talk about HPC in particular, it is clearly an enabling technology for the rest of our applications, software applications. Without a proper simulation environment, where HPC is clearly part of an IT environment, you're never able to succeed in using our software applications. In order to scale up, for example, HPC, you better make sure that you have the right environment in place, that you have the right IT infrastructure in place, that your software applications run most efficiently on your hardware, being supported by the right job schedulers, by the right remote visualization tools, by the right processor types and so on. So we are making sure that our applications run most efficiently on the infrastructure of the customer. In that sense, it's a very key enabling technologies for the rest of our software applications. We have applications that range from structural mechanics to computational fluid dynamics to electromagnetics to embedded software, and each of these applications have specific requirements and bring specific functionality in terms of HPC. For example, due to the nature of the computation algorithms, it's clear that computational fluid dynamics scale at a very high core count nowadays. Typically, our customers run between 128 cores and 256. But it's going up, they scale up HPC because clearly our customers want to run faster, bigger and more simulations. And for that matter, and in particular in the CFD area, there is a continuous demand for HPC scale up in that sense. Due to the algorithms, as I mentioned already, structural mechanics is scaling at a lower core count level. Nevertheless, we make sure that release by release we make improvements there, and nowadays we have even proven that with Ansys 17 our structural mechanics suite scales up to even beyond 1000 cores. So we made significant progress in that area as well as in the electromagnetics. But coming back on CFD, for example, we reached a milestone with Ansys 17.0 where we with that release of 17.0, we were able to achieve for a single job running on 129,000 cores, so 129,000 cores, with a parallel efficiency above 92%. We are continually getting demands from the industry in order to achieve scalability, which makes possible to run complete engines. That's the ultimate goal, for example, of the companies like Airbus and all the aircraft manufacturers. They ultimately want to simulate their entire engine. Like Airbus, they want to run real-time CFD in-flight simulations. And for that matter, they really need to run their CFD jobs on not only on 10,000s of cores, but even beyond that. There is clearly a continuous demand for HPC scale up and scale out. For example, one of our customers, Tetra Pak, they have very challenging sterilization of packaging products. They want to optimize that process, and for that matter they need very complex so-called LES type of CFD simulations. There is clearly a demand to go beyond 10,000 to 100,000 of cores. And as we've demonstrated by Ansys 17.0, our CFD software scales beyond 129,000 cores. Actually, that was the limit of a cluster we could even get. And this improvement which we make, by the way, has a clear spin-off also at lower core counts. Because the more we can improve our parallel efficiency at the high core count, also the smaller problems can benefit at the low core counts. There is clearly a demand for HPC scale up and scale out. And we see different categories how people can enable that. Clearly, Our enterprise customers, they are in a process of consolidating their data centers, still most of the time on-prem. They're consolidating, they're bringing the number of data centers down in order to optimize the IT efficiency, to make sure that collaboration works most efficiently across the globe. And some of those customers are also moving their customers in the cloud and consider, for example, our enterprise cloud solution, where they consider our enterprise cloud as an extension of their network, where they can scale up and scale down the compute resources as they wish, as needed for a specific project. But we have also, let's say, the SMB customers who want to scale up. They have also very complex models to simulate, complex problems to solve, for which they'd like to get more insight out of simulation. They also want to scale up, but they often lack the IT experience or the IT knowledge or even the IT infrastructure to scale up. And for that matter, those companies consider now to move also in the cloud. They consider one of our cloud hosting partners, where those cloud hosting partners provide services, cloud services, sometimes even on-site services, and otherwise remote services in the cloud, where they have our software, they have remote visualization tools, they have a compatible platform, cloud platform for our software applications, and where our customers can go to and outsource basically their HPC work to those cloud hosting partners. Yeah, if you talk about the automotive industry, you clearly have the tier 1, the tier 2 suppliers. You have the big OEMs in that respect, and they all work together, of course, and they want to work, and that's clearly meant to, in order to bring their products quicker to the market, they need to collaborate more efficiently. So networking is there extremely important, that they work on the same data sets, for example, consistent data sets, that they have sharing the same models, but that they also make use of good compute resources. And of course, you have the small suppliers. They may not have the equipment or the compute resources the big car OEMs may have. They start off by using our applications on a workstation. If more engineers are starting to use our engineering simulation, they go typically to a server, and they evolve. They are on the journey from workstations to servers, and move gradually into cluster deployments, where they can really scale up. And for that matter, they often go to some of our system integrators. They are partnering with us also to simplify cluster deployments, because those smaller suppliers may not have all the knowledge. And for that matter, we are working with companies like the Dasher in the US, like the Total Linux XISS, but also Total Linux here in France, with ICT GmbH in Germany, where they're actually supporting our customers in cluster deployments. Because needless mentioning, that is not that straightforward for those smaller SMBs. That is even sizing, provisioning a cluster, setting up a cluster that is optimized for our applications is not straightforward. Very recently, actually, we have introduced a completely new licensing model, new business model, that is actually addressing the needs from customers in terms of fluctuating demands for software applications, for HPC resources, and that is what we've introduced at the end of March 31st. Actually, it's a pay-per-use licensing model, basically addressing fluctuating demands from customers, where it is complementary to the traditional lease licenses, where they typically use our traditional lease or paid-up licenses for the average workload, but once they lack the capacity in terms of licenses, they consider the pay-per-use licenses and having the fluctuating demands being addressed through this pay-per-use licensing, because then They will never be constrained in terms of licenses. They can use that in conjunction with cloud compute resources, which is also providing this elasticity in terms of compute resources. They can scale up, they can scale down. That is now also available through the Ansys elastic licensing. Simply they buy a pool of those so-called elastic units, and every product consumes a number of those elastic units per hour or fraction of an hour, and it will start counting down. Yeah? It can run into an overage situation where people consume more than they own, but they can continue to run. So basically they are not limited in terms of licenses anymore, and they have the flexibility to get access to virtually any of our Ansys products. I think it typically, if what we see in our space is that customers start to deploy our software on workstations, and sometimes even relatively small desktop computers. Often it's just a single user. Once they start using it in a larger group of people, there is a need for scaling up in terms of compute resources. They go to a server, a typical bigger server where more people will have access to that server, start sharing that among the customers, among the users, using a server for Ansys engineering simulation applications. If the group grows and if the models becomes more complex, we see that people evolve in the cluster deployments and start deploying either a cluster on site or consider to move on the cloud and take advantage of compute cloud resources from cloud hosting partners or from AWS through our enterprise cloud solution. So that's a very typical journey our customers are on, and every customer is having a different pace in that way. It's clear that once you are very mature in your application, you've proven the workflows, and you haven't set up an engineering group of people, then you better have an infrastructure supporting you where you can share your models. And then a cluster is a very natural resource in order to meet your demands on the engineering simulation side.